I'm Linopolis Noha. I'm the Director of Owners Engineering at Camelot Energy Group, and I'll be your moderator for today's session, which is part 3 of our Camelot and TWAICE webinar series, Constructing BESS Projects Without the Chaos, Engineering and Commissioning Insights. We're excited to have you join us as we explore the engineering and commissioning phases of battery energy storage projects. This session will highlight best practices, common challenges, and lessons learned from the field. Before we begin, I'd like to just run through a few quick housekeeping notes. This webinar is being recorded and slides will be made available to all registrants after the event, or please email us at hello@Camelot Energy Group to get a copy of these materials. Please note these are not for distribution. Feel free to use the question box to post questions or comments. However, all participants will be muted for the duration of the webinar. We aim to have about 5 minutes for questions at the end. We appreciate your participation, so if you would like to leave feedback, please email us and share what you liked and didn't like, as well as topics you would like us to cover in the future. Without further ado, let me quickly introduce our speakers. Aaron King is the Senior Project Engineer at Camelot Energy Group. Aaron brings deep expertise in BESS design and integration with a focus on optimizing performance and reliability across diverse project environments. Aaron is joined by Matt Drazanovich, Senior BESS Engineer at TWAICE. Matt specializes in battery analytics and lifecycle modeling. His work supports smarter commissioning strategies and predictive maintenance for energy storage systems. In today's agenda, we'll be laying the groundwork for smooth commissioning. We'll be discussing the importance of long-term service agreements. This will be presented by both TWAICE and Camelot, and digging into some data considerations led by TWAICE. What to watch out for during construction. Aaron will discuss some contracts and coordination aspects, site readiness, data and instrumentation readiness, and also share some real-life case studies. Avoiding delays, cost overruns, and late-stage surprises. We'll be discussing some safety protocols, the most common failures, and also leveraging data, how to leverage data to decrease investigation time. Then finally, we'll look at what ready to make money really looks like, determining sufficient testing and inspection, and then also data-driven commissioning and test analysis. We're really looking forward to a dynamic and insightful conversation. Please feel free to submit your questions throughout the sessions. We'll address them during the live Q&A at the end of the webinar. Let's get started.
Thank you, Lynn. And yeah, thanks for introducing the agenda. So we are, see if I can get to the next slide here. We're basically covering 4 sections of the commissioning process, everything that you see on the screen here. And really what we want to first focus on is the planning phase. So there's a lot of things that you can plan for that will make the entire commissioning process go much smoother. And a lot of that comes down to contracting and LTSAs and these sorts of things that you can get in place. So Aaron is going to kick us off with this.
Great, thanks, Matt. Yeah, so kind of any project, I think we're really hoping to get to this final stage, having it market ready, having an operating project, and we really wanted to kind of bring it back in time and go all the way back to the planning and contracting phase. And so kind of any successful project is going to start with comprehensive contracting. Let's see, we can go to the next slide. Great. Yeah, so, we see different projects at different stages coming out of the development stage and entering the construction phase. And often at that time, you're going to be looking at finalizing an EPC contract, maybe a BESS supply agreement and a long-term services agreement. But at that point, there are already going to be contracts in place from the development phase, right? So you're going to have an interconnection agreement, you might have a lease, tolling agreement, and it's really important to kind of properly reference and consider all of these existing agreements when setting up your EPC contract and your supply agreement. So your EPC design really should be making sure to consider the interconnection agreement requirements and the lease terms. Also, it should match any permitting requirements from the AHJ. And your BESS supply agreement should be matching the use case, again, dictated by the interconnection agreement, or maybe the ISO and the different markets that it's going to be participating in. In terms of these two major contracts, we really want to see a focus on including a clear division of responsibility. So the EPC agreement and BESS integrator agreement, sometimes those are separate. And it's important that everyone's on the same page and there are no scope gaps. And not only do you want to make sure that all the scope items are covered by at least one company, but also often there needs to be overlap. And so, one example we'll talk about a little bit later is ensuring that the network design and the communication strategy, making sure that that works properly is really both parties' responsibility, and they may need to work together and to coordinate, making sure that's kind of in the scope of both entities. And finally, you have your O&M agreement and your long-term services agreement, or your LTSA. And we think it's important to highlight that these should really be executed as early as possible. We found that asset owners waiting until later in the timeline to finalize these have caused problems. You really want to have your LTSA managed by your integrator, and it's a lot easier to negotiate favorable, comprehensive LTSA terms and conditions when you're kind of also negotiating your BESS supply agreement. And so if you wait until later, you may have less leverage there. And then also the O&M agreement, sometimes we see this used interchangeably with long-term services agreement, but sometimes there can be a difference. There might be other items outside the LTSA, such as maintaining site vegetation, maintaining some of the metering or the transformers. And so kind of making sure that you have a comprehensive O&M strategy that includes an LTSA, but also might include some other operations and site management. And that the LTSA is definitely an item that we see. It can range a lot. We see many different types of LTSAs that have a wide range of different services that are being provided and the different assurities. And so kind of want to hand it back to Matt to talk a little bit about what we want to see in an LTSA and kind of what we encourage to have included there.
Thanks, Ryan. Aaron, we run into this very often at TWAICE when we're onboarding new systems, especially if we're coming in during the commissioning phase. And I really want to reemphasize Aaron's point about getting these things in place as early as possible. So the first one we oftentimes run into is having no agreements in place or real plan for having access to data, or how data is going to be logged, or who's going to own the data. But then even once we get past that point, as we're doing analysis on various sorts of testing, oftentimes the language is very ambiguous in terms of what does the capacity really mean, what does availability down the road really mean. Our whole team actually spends a lot of time trying to go through different LTSA contracts to develop our warranty manager, and what we oftentimes see is just generally very ambiguous language. And there's also a lot of language that doesn't allow you as a customer to really enforce any issues that come up during commissioning or even after. TWAICE actually has generated an LTSA guide to give some guidance on what to look out for when evaluating these contracts. So if you scan the QR code on the screen here, you can access that. There's a lot more information to be found in there. But once we have LTSAs in place, there's additional planning that really needs to go into construction and how you're going to store your batteries, and planning for fire safety and these sorts of things. So Aaron's going to walk us through those.
Great, thanks. So kind of once you've wrapped up your contracting and construction starts, we definitely have lots of things that we like to look out for and encourage developers and owners to keep an eye on. We could do a kind of whole webinar on construction, but I just want to hit a few of our biggest topics and favorite or least favorite pain points. So the first is really the the battery procurement considerations. You want to ensure that you're going to have factory acceptance testing and manufacturing QA/QC. This should really be provided by your OEM prior to shipping, and you want to make sure that you're not taking control of equipment that's not working properly. Next would be coordinating storage and delivery, whether this is between your OEM and integrator, or maybe between your integrator and the owner or the EPC. You want to make sure you know where these containers are going to be delivered and stored. We like to recommend that containers are kind of stored off-site in controlled environments for as long as possible. But if they do have to be moved on site, we want to make sure that there's going to be proper thermal management during construction as well. Talk about that a little bit later. In terms of design drawings, I think most of these types of projects, we can go back one slide. In terms of design projects, we see electrical, civil, and structural elements in many electrical projects, and making sure that those are consistent. We don't see quite as many problems there. I think the biggest thing I want to highlight is the focus on the SCADA and the networking design, the communication protocols. There are a lot of different stakeholders, a lot of different equipment that needs to work together. And a lot of BESS projects, we feel it's a very customized solution depending on what ISO you're in, depending on the utility you're working with, depending on what equipment you have on site. And so kind of making sure that there's proper coordination of those designs, that they've been reviewed and approved by all the necessary firms is going to be important. And we really want to see that again prior to construction. Sometimes I see the SCADA and network design kind of still getting worked out during construction. And that's always going to almost inevitably lead to an extra conduit needing to be run that wasn't designed for originally. And finally, during construction, we see a lot of market changes. The industry is evolving quickly. And so there may be reasons why you want to re-optimize the system size during construction. You may want to adapt to new state incentive programs that have come out between development and construction. ISOs are modifying their tariff structures. I've seen state programs and local utilities change their metering requirements retroactively on projects, and you kind of need to adapt to that. So kind of being ready for those type of changes and being flexible definitely has opportunity to kind of further optimize your project even after the development stage. Go on to the next one. Just again, kind of digging a little bit more to BESS storage. We see, storage, we see projects, we really want to keep the equipment stored off-site for as long as possible. Ideally, it would remain in the control of the OEM. But if not, and it must be moved on site, or you must take control of it, we want to make sure that kind of your storage conditions are matching your manufacturer guidelines, and you're meeting your humidity control and your temperature controls. It's also kind of best to have humidity and temperature monitoring and data logging. That can be helpful in the future. If there are disputes with the OEM, you want to be able to validate that you did meet those temperature ranges and properly maintained it through construction. So here we have some photos of some humidity control effects and also temperature and humidity sensors that are being stored on site during construction prior to energization. Also, very common to bring in generators and kind of run the thermal management systems while the batteries are stored, especially if you're in particularly hot or cold environments or hot and cold weather. And on the top left here is actually an example of a project where there wasn't, kind of proper sealing and humidity control. This is one of the control cabinets, and you can see there was some water damage that definitely caused some delays during commissioning. So it's kind of very important to kind of maintain the environment inside these containers through construction. And finally, again, for construction, it's very helpful to have a manual transfer switch. We're seeing this almost in all projects will have some sort of manual transfer switch or equivalent, so that you can easily connect an external generator to power the system. And that's not only helpful during construction, that can also be helpful during operation if there are kind of extended utility outages, or you need to provide temporary power because you've lost utility power because really just any amount of time that the system is left unconditioned could void the warranty. Next, again, is another topic that could be its own webinar, BESS fire safety. But I just want to briefly talk about BESS fire safety kind of during construction, which I think isn't always talked about. Before, just really want to highlight that there has been great improvement in the industry from fire safety. We've seen a drastic drop in the number of thermal events per deployment over the past 6 to 7 years. You can see that in the graph in the top right here. However, it's still important to stay vigilant and understand the risks. And, we wanted to highlight that there is a risk present even before the commissioning and operation of batteries. There were actually two kind of high-profile battery fire events in New York State in 2023, both of which occurred during the commissioning before the systems were placed in service. And so for this reason, we now recommend that projects create an emergency operation plan, also called an emergency response plan sometimes, before BESS are delivered to the site. So this should be included, this should include specific hazards. It should list automatic system responses. There should also be guidance on actions that first responders should take, and detail communication protocols in case of an emergency. And I think that a lot of times this is kind of done by the end of the project, and by this time the system is operating as part of the closeout package, but we like to see this now earlier, before the batteries are brought onto the site. Again, in practice, these documents have started to become very long with a lot of safety information, a lot of product details, kind of all included in almost like one pamphlet or one booklet. But we also recommend creating kind of a 1 to 2 page summary sheet that can be posted in a visible location for first responders that is easier to follow, so you can gather the most critical information in case of an emergency. So next one, again, I think this is kind of the transfer from construction into commissioning, and kind of wanting to highlight again this BESS network and tech stack. I think that, the first piece of advice we have for projects is making sure that there always is a high-level network design diagram. It may be referencing many different subcomponents of the system. It may be referencing many different different companies and different stakeholders that need to kind of coordinate. And so there's been projects where I haven't kind of seen the big picture brought together, as there's lots of different drawings that need to coordinate. So I think having a diagram like this is very helpful in kind of managing the meetings, making sure that maybe project managers for the system owner or for the EPC have something to kind of visually understand how the systems are coming together and what stakeholders need to communicate to make sure that there's proper integration. And like I said before, I think, with the electrical and structural and civil drawings, a lot of times those are finalized prior to construction. Everything's approved, everything's stamped. But I often see a lot of the final details of the SCADA design and network integration not really fully finalized deep into construction. And that's always going to really cause delays during the commissioning if you're still figuring out the final details. You really are going to have network engineers on the phone coordinating with each other. And so really one of Camelot's main roles recently on projects has really just been helping coordinate these different stakeholders and make sure that there's a division of responsibility, and that there's a clear roles for each party, and everyone has the information that they need to finalize their network settings and the different devices that need to integrate throughout the project. And I think I know, Matt, also, this is an important part kind of for when your work begins as well.
Yeah, exactly. It's something we bump into quite often where, we get asked to come in and help with analyzing commissioning, whether that's just, the testing here and there that's going on as equipment's getting brought up, or, the actual commissioning test. But, we don't always have great access to the data at this point. In this diagram, we show sometimes there's a local data logger historian. Ideally, there's some sort of cloud storage of that data as well for longer term storage, and then from there, it's that's how you're going to be oftentimes sharing data with other stakeholders offsite. So being a TWAICE, we're in the BESS analytics realm. We have to always try to figure out where we're going to tap into this, and we also run into things like cybersecurity requirements and specific firewall settings and stuff that we have to work with to get access. So having that planned for ahead of time, ideally in place when the testing starts, can really speed up commissioning in terms of just being able to actually like root cause and diagnose issues as they come up. So on that topic, let's see if I can get the slide to go here. Okay, yeah, here we go. TWAICE being more focused on the data aspect of BESS operation. I think we see some assumptions that folks have going into some of these projects. So for example, just because you have any like the EMS is in place and the SCADA's working doesn't necessarily mean it's really been fully vetted, and we see sensor mapping issues quite a bit. Sometimes you can see some data, but is it all the data that you need? A big one is like, where is the data being made available, who's storing it, what are the access rules, especially around beyond that, like how the data is actually structured, like what is the logging frequency, which sensors are actually being logged, is it being logged in a historical fashion, and then from there, like we try to make sure that we have access to it, the necessary stakeholders do, but then really where the analytics side of things comes in is trying to leverage that data to give more state-based insights. So being able to plot time series data is one thing, but when you can start really tying sensors together to understand the state of the battery, you can really look under the hood of the actual operation a bit more. And then, also just making sure that you have folks that can help you to really internalize and make use of the insights that you're getting. I've probably seen this next slide before on TWAICE webinars, but in the past we've worked with EPRI to really try and quantify types of failures that we see in the industry, and I think so 60% or so of failures occur in the first 2 years of operations with a BESS system. And oftentimes these failures can be, root caused back to balance of systems, so which is essentially the integration. And a lot of these are introduced during the commissioning process. So, the equipment's made, it goes through some level of factory acceptance testing. Hopefully that's thorough. And then the site acceptance testing is really where you're going to be catching all of the assembly issues that pop up. And some of those are not always as obvious to catch as others. Some of it can be visually inspected. Some of it really does take having a closer look at the data. So with battery analytics, we always try to say that where we maybe differ from just having access to tables of data or maybe some time series plotting is being able to find the needle in the haystack by correlating a lot of different data. So for example, we look at different KPIs, energy throughputs being the most basic one. We look at that not only at the system level, but at the component level across the system to see if everything is being discharged equally. We look at DC resistance, so really looking at what the voltage drop is under a current pulse for different parts in the system, potentially highlighting things like loose interconnects. With that, we also look for weak cells, which might be indicating loose interconnects more at the cell level. Voltage spreads is more along the lines of we want to understand if the voltages within a string are all being are all essentially equal throughout the discharge or charge profile, which if they're not, will definitely lead to capacity loss in the future. Temperature performance. And another interesting thing that we tend to see is things like related to more of the actual data side of this. So SOC drift and asymmetric discharge current. We would expect that a brand new system is able to basically discharge all components at the same rate, and that you'd see more of a linear SOC curve as you're going through the charge and discharge, but we oftentimes see quite a few anomalies in that data, which can be addressed earlier on. To give maybe a bit of an example here, this is just looking at a capacity test. What we, first question is, did the system actually meet the expected capacity, whether that's contracted capacity, nameplate. And then, if it didn't, or even if it did, we still want to go and look at like what all the components in the system actually did. So the plot here shows a few containers in a system, along with the average throughput for each string in each container, relative to what we would expect the nameplate capacity of that string to be. And you can see that one achieved it, but many didn't. So then it becomes a question of, well, why? And then you can dive into a lot of these other KPIs to actually try to understand what's going on. And an example like this, this is something we actually found. Voltage imbalances are often a huge one that we can tie capacity loss back to. In this case, you see one rack having a much larger voltage imbalance relative to all the other racks. Depending on the architecture, that can actually limit the entire capacity of all racks connected in parallel. But then we also see things like asymmetric current. So here you'd expect, if you tell the system to discharge, that all components are going to turn on and discharge at the same time. But in some cases, in this case, they turn on, 2 racks turned on late. And then a big one that's been coming up lately is just state of charge anomalies. So in the plot on the right, we can see large jumps in SOC for some racks. And while they ultimately start and end at the same point, these SOC anomalies can ripple through up to let's say the EMS level system SOC, and basically give the EMS a wrong idea of where the system is actually at. And if you have racks turning off earlier than expected, it might take down all racks connected in parallel, and these things like this.
Yeah, thanks. Yeah, I think a lot of the kind of tests that Matt are showing are just really valuable through the commissioning process. It's something that often is not really picked up until much later in the operations of projects. And even during the commissioning, it can be hard to kind of maintain pressure on your OEM, on your integrator, to kind of validate the results of their capacity test, of their step tests, and their voltage balance tests. And so I think kind of having that type of oversight and that type of view into the data can be really valuable into moving your project forward and making sure that you have a healthy project. Similarly, I think a lot of these tests that we're talking about are very typical of what we see for site acceptance testing. I think we kind of see a lot of critical milestones defined in EPC agreements and in supply agreements that'll usually be mechanical completion. Maybe there's permission to operate from the utility, placed in service, commercial operation date, substantial completion, final completion. And so these site acceptance tests that we're showing on the left are almost always included in those, right? You're going to have your capacity test. You're going to have a round trip efficiency test. You'll have your witness test from the utility. You definitely need to close out all your permits. So I think we always see those included in the kind of contracts, but that doesn't really necessarily mean that the projects are fully market ready, and that they're able to kind of take advantages of all of the revenue streams that they're expected to and that they've been designed to. And so we also kind of want to start encouraging folks to keep this in mind and understand that your project isn't fully commissioned until it's really passed all of the different tests and is really generating revenue in every stream that it's allowed to. And so some examples of that, right, would be tests with the ISO, especially around ancillary services and qualifications for those services. So for ISO New England, for instance, you might want to participate in a frequency response program. And so you'd kind of have an automatic generation control set point test that they want to run you through to ensure that the asset can respond to the set point signals coming from the dispatcher. ERCOT has a number of tests that will show on the next slide for different ancillaries that you could take advantage of and that you will need to run through to prove that you're ready and qualify for those programs. And then also you have state incentive compliance, right? So programs that have certain paperwork, that might have data validation that's required. And so we don't always see, contractual milestones tied to some of these very critical tests. And it's important that that your that your EPC, that your supply agreement, that your manufacturer, your integrator, are also tied to you successfully completing these tests, and that the project is really ready to operate long term. I'll go to the next one. There we go. Yeah, so again, ERCOT has a number of different tests that you'll want to run through to make sure that you can take advantage of all the different ancillary services. These are a handful of them. The telemetry tests are going to have to prove 2-second updates for real-time operation data, and coordinate that with ERCOT. You're going to have your dispatch reliability reserve service. You're going to have your nodal protocol revision requests, all these different tests that they're going to run you through. These are all items that a lot of times your qualified scheduling entity or your QZ should be handling and managing. However, if passing these tests were not a requirement under your EPC agreement or your supply agreement, then you may have key contractors who have kind of finished their scope, they've received their final milestone payments, and they might not be working on the project anymore. But while going through these tests, you may need folks to be on site to run through some more tests to make sure that everything is okay. So we really think kind of including these in the requirements of substantial completion or of final completion really help ensure that all the relevant parties are present until the project is really market ready. And then the next slide, again with the state incentive programs, a lot of times, this is the responsibility of maybe the owner, kind of walking through some of the paperwork. You might need to coordinate a final QA inspection, like they're doing in New York, either under the VETR program or their new bulk and retail storage program. And you might have kind of meter data submission and validation to make sure that you qualify for these different incentives. So again, right, you kind of want to make sure that all the relevant parties and all the contractors are kind of with you through this process in case there are some other details at the site that need to be worked out before the project's closed out. And I think with that, we've kind of gotten to where we wanted to get with this webinar, which is really hitting a place where the system is operating and participating in the markets that you want to, and is market ready. And so what's the last slide here?
So I think, thank you, Aaron, thanks, Matt. We're now heading into our Q&A section, and I just would like to encourage folks, if you have any questions, please pop them in the Q&A. Just in the top, you'll see the icon where you can put any questions for any of our presenters. But we do have a question from Andrew Lowry. Matt, if you want to hit to slide 13, there was a question that Andrew wanted some clarity on.
Sure. I don't know if I can actually go back in the presentation.
Okay, well,
but I do know what slide that's referring to. There we go.
So there you go. So the question is really, what percentage of the failures were in the first 2 years of the commissioning?
Yeah, so the study official number was 59%. Actually just recently took the slide out of here, but just the bulk of the issues are happening, 59% of issues are happening in the first 2 years based on this sample that EPRI studied. Okay.
Thank you. And I think the interesting thing is definitely from a balance of system, there's a large percentage of failures that are identified fairly early in the project development, and that is because of either workmanship or issues that were as a result of your balance of system. And I do not see any other questions.
Maybe to add on this a little bit, I think in a perfect world, when everyone's coming, all the stakeholders are coming together to make this project work, any project work, everyone should be able to, check their own work and be able to do the inspections and make sure everything's good to go. But it's generally not always the case. So I think being able to arm yourself with a bit of knowledge about what is actually going on with the site really helps push to get these issues remedied earlier, whether that's discovering the issue in the first place through, things to look for that Aaron highlighted or that we at TWAICE highlight, but also being able to arm yourself with the knowledge and in some cases data to take that back to really push for fixes to get handled early on.
Yeah, and just to touch on to that, Matt, in terms of the process for verifying OEM performance claims during commissioning, can you speak to what that process is and how the analytics can support that process?
Sure. Yeah. So when we have access to the data for the system, if we just take like the capacity test example that we showed, it's starting off making sure that where is the system landing in terms of DC and AC capacity. Is it meeting it at least at that high level? And first, the first part is really checking that it's actually going to meet the requirements, either for at the nameplate level or with the with the OEM. If there are issues, or even if we see potential issues, we still do highlight them. So basically our commissioning process is we have a fairly automated way to generate a lot of these insights. And then when we produce a report for clients, we have a team internally at TWAICE that goes through the system with a fine-tooth comb and tries to highlight any anomalies that we see in the data that could be potentially immediately remedied with the folks on site.
Thank you, Matt. We have one more question, I think, which is very, either Aaron or Matt could take that on from Mohit Jawal. For capacity test of BESS, can we rely on the OEM BMS data, or should we utilize an external DC and AC power quality analyzer?
I can take that one, or we probably both give some answers to this. I think when we look at the data, we're typically able to look at multiple aspects of the, let's say, energy measurements, power measurements. In some cases, we're looking at and aggregating all string power measurements. In some cases, we're looking at the meter output. And really what I don't necessarily know that you need to add an external measurement device based on my experience. But being able to have enough data to correlate, I think, is where it becomes important. So if you're seeing a huge deviation between what the aggregated string currents are and what the actual DC inputs of each PCS are, that's where you can highlight that there is going to be an issue. And I think that's where data really comes into help with that analysis.
Okay.
Yeah, I would just add on. I would agree with that. I don't think you need to bring in an external, kind of PQ analyzer, but you should be kind of looking at all of the data that's available on the site, right? So if you have a separate POI meter, should kind of be able to validate some of the results and kind of bring things together. And I think kind of the stuff that Matt has talked about, kind of the validation there. Is going to be important. We've definitely kind of reviewed a lot of capacity test results, and I think those are a lot of times coming from the BMS data, and I think that's okay. But kind of just making sure you're also looking at everything else that's available to you to make sure that everything kind of makes sense.
Thanks, Aaron. We have just following on from the earlier question around balance of system, balance of plant issues. What are the most common issues, Aaron, that you have found during the design and construction phase, and do you have any advice in terms of mitigation or how to address those kind of any kind of remediations that you can recommend?
Yeah, I think it's what I've seen is kind of the integration of the different components. If it's not a vertically integrated solution, right? So something we've seen a lot in BESS projects that are coupled with PV is you have a battery system. Maybe it has its own inverter. If it's AC coupled, maybe it has a DC converter if it's DC coupled. And you have a key integration between the different inverters on the site or the different power conversion systems on the site, making sure they're communicating properly, making sure that they are compatible, I think is something that we've seen a lot of issues with. And that kind of ties back both to those pieces of equipment, but also to the SCADA integration to the DAS system. And so, I've been working with manufacturers from a DC converter a manufacturer with a BMS provider, a manufacturer with an inverter, and you have kind of 3 different entities there that need to work together and make sure their systems are communicating and that their systems are compatible. Similarly, I think metering has been an interesting one. You know, we've seen in some jurisdictions there or some programs want to see have different metering requirements, and you know, maybe they want meters on the DC side, power quality meters on the DC side, revenue grade meters, and so kind of making sure that you understand what your utility or what your incentive program wants to see is going to be important, and making sure that the equipment you have can be kind of retrofitted or can be ordered originally with the metering that you need.
Yeah, I can. In a previous life to TWAICE, I had dealt with meter issues and communication issues generally quite a bit. And yeah, I guess maybe specific to balance of system for what we've seen, I think anything that is coming down to interconnects, specifically interconnects that have to be made on site, and potentially HVAC issues, making sure coolants are topped off and these sorts of things.
Thanks, Matt. I think that, folks, I think we've covered quite a lot of ground from the commissioning basics. We've discussed a lot of some of the construction issues that you could still be lingering even during commissioning, and right through to your capacity testing. And also looking at some of the deeper requirements that is needed for true market readiness. So we hope today's session gave you clarity on what it takes to go from commissioning to confidently participating in whatever market whatever market you're participating in. If you have any follow-up questions, please, or you'd like to dive deeper into any of the topics, we're happy to continue the conversation. Again, finally, thanks for your time, and we look forward to seeing your projects thrive in the markets they were built to serve. Thank you, folks.
Thanks, everyone.